Good evening, and I welcome all my students in this session on embryology. And like I said, I've just mentioned how important this session is. It's going to form the basics of your, many systems which are going to come up. And remember that we're talking about embryo proper right now. So my main focus is going to be on the 3 germ layers. All right. So you have a lot of things going on. You have the connecting stalk, you have, the extraembryonic coelom, the amniotic cavity pinching, and then the chorionic cavity pinching up, and how is it formed. So these things are going to be discussed definitely, but the importance is going to be on those 3 germ layers and what happens with them. So, and of course, by the end of the lecture, I'll also throw some light on the placental changes that are taking place. And in the whole of pregnancy, not a lot of changes take place in the placenta. It's only in the initial few weeks that placentation is dynamically evolving. But after all, it's almost stagnant. It's just maturing. There's not a lot of changes that go on. But as far as embryo is concerned, it keeps growing. A lot of changes take place. Different organ systems are, budding from a very, very, absolutely confluent mass. A mass of cells suddenly becomes into a full-grown fetus. Just imagine. So a lot of changes are taking place. That's what we are focusing on in embryology. And when I used to, study embryology in my postgraduate classes, it was a very, very difficult thing for me to understand how, things, there's going to be these questions on rotation of the midgut. There's going to be questions on notochord formation. It was not, entering my mind how these things take place until unless, you see these graphic videos, which I've deliberately included in my lecture today, so that you get a better understanding of what exactly is happening, because not everything is happening in 2 planes, all right? Just the 2 X and Y dimensions, it's not taking place. Things are happening in 3D dimensions. So important 2 announcements also I'll make for you guys. First of all, I think most of you know that December 22 paper has also been added to my answer bank. So those of you who are, going through this June 23 theory paper should go ahead and see that. Those who've already bought it, like I always say, it's already added to your already bought package. You don't have to separately purchase it. It's going to be updated automatically. And all the changes that I keep doing, they get updated automatically. Until unless, of course, it's a very, very huge shift of package that I announced as a separate package, right? That was one announcement. The second important announcement is regarding the anatomy series that I'm taking. I hope all of you who are right now over here have also subscribed to my channel on YouTube. Why am I saying that? Is because there are certain classes that I'm taking on YouTube separately, especially the anatomy series. I wanted to take it with my with all you students over here, but it was separately asked by many other students from a really long time. So I thought I'll just, and I started it already when we were doing our vaginal hysterectomy workshop. At that time only I started with anatomy series. So in that way, it was like somehow kind of discreetly there on YouTube. So it's there available on YouTube, the lectures, and now I think when anatomy series part 7 or something is going to be announced. So please follow those lectures as well, because it's again trying to help you out to understand anatomy through 3D figures and 3D structures, and it makes it a little more easy and fun to understand, right? Rather than the drag thing that you read from the books. Otherwise, everything is there in the textbooks, like I always say. So recently, I've taken ureter and ureters in anatomy and lymphatic drainage, and now it's going to be on arterial supply and stuff is going to be remaining. So, anyways. Now today we'll be discussing about this embryology, and let's start with the basics. So the first slide, as you can see over here, I'm just trying to tell you separately the gametogenesis, right? So the question also comes on this gametogenesis. I separately included it in my theory course as a topic, and many of you were asking me what exactly do you have to write in this. So it's both. Okay, it's both. Gametogenesis, when I talk about, it's about the like I say, the ovary and ovulation. And when I speak about gametogenesis, also means spermiogenesis. Okay, so oogenesis, spermiogenesis is 2 topics, and you should know a little bit about it. So I think my slides are going to do the justice with this topic. So what you can see in this slide is that how it evolves right from the oogonia, okay, the primordial follicle. So when a baby is born, a female baby is born, a female fetus is born, it has a lot of these oogonia, primary or primordial follicles inside, and millions. And then by the time finally it kind of reaches puberty, only a few are left. 2 or 1 million is left, and then even that thing dwindles down to a lot less in number. And then finally, some of them are able to ovulate, most of them die out or get atretic, right? So we're now trying to focus on those follicles which actually get a chance to ovulate. Okay, my focus is on that. So how a primordial follicle, as you can see the oogonia over here, gets into forming a an active follicle activation and goes on to forming a primary follicle. Now, if you see over here, see the primary follicle from a primordial follicle, not a lot of difference is there. It's just that, you have a single layer of granulosa cell separated by zona pellucida. The covering comes a little more, dense and consolidated covering of zona pellucida comes. Remember zona pellucida because somewhere down the lane, basal lamina will also come. Do not confuse the two. They're two separate coverings, okay? Then you go on to seeing a primary follicle where you can see the zona pellucida and you can see a few layer of granulosa cells separated by that, as you can see outside. Otherwise, there was an internal mass which was developing, okay? So then you have this primary kind of follicle developing into a primary oocyte, as you can see over here. And it's got multiple layers of granulosa cells. Over here, you had 1 or 2 layers, just a single layer, of granulosa cells. And over here, you've got multiple layer of granulosa cell, as you can see. There is no antrum as of now. Okay, no fluid-filled cavity is there. So this is still a primary oocyte. When I jump on to say a secondary oocyte, okay, this is a secondary follicle, but still a primary oocyte. There is a reason why I say so. This is a secondary follicle, but a primary oocyte. Why? Because up till now, the meiosis has not taken place, right? The complete meiosis, meiotic 1 division has not completed. If you know this, meiosis starts very early, at a very infantile stage. Meiosis 1, it starts, but it gets arrested at prophase 1. When does it complete? The meiosis 1 gets completed right before ovulation. Okay, remember that. Not after ovulation, before ovulation. So meiosis 1 is completed before ovulation, and right at the time when meiosis 1 is completed, then that time you get secondary oocyte. So when I talk about this early tertiary follicle and I talk about mature Graafian follicle, it's actually haploid because the polar body has been given away. Okay, I'll straight away bring you to this. This is a picture taken from a book. That's why it's like a little kind of hazy. But what I'm trying to say is that right before birth and even in childhood, this is the stages which are going on. So these are diploid numbers because mitosis is going on. Lots of primary oocytes are being produced. Okay, lots of them. The growth takes place, and many of these primary oocytes are lost in the way. And finally, from childhood, then you go to puberty, and then you go to the time when the ovulation is about to take place, the meiosis 1. See, the primary oocyte still arrested in prophase 1 finally undergoes a meiosis 1 is completed. Okay, the first polar body is extruded out, and a secondary oocyte is made. Secondary oocyte is here. As you can see, this is the tertiary follicle, the early tertiary follicle, and the mature Graafian follicle, which is still not extruded out the ovum. This is the ovum, guys. Remember this. Here is the Graafian follicle. I'll tell you a little about Graafian follicle also, because that is also asked in your exams. Okay, as a short note on Graafian follicle. Now, you will be stupid enough just to write about Graafian follicle and not make a diagram. This is why I try to explain it to you in every class that I take, be it on YouTube or be it the live class, how important the diagrams are. Just 2-3 lines on Graafian follicle and a very well labeled diagram is enough to fetch you from 2 marks to 5 marks, anywhere between 2 marks to 5 marks. Even if the question is asked for 5 marks, that's what the examiner is looking forward to. A few couple of buzzwords like theca externa, interna, basal lamina, zona pellucida, cumulus euphorus. These are few buzzwords the examiner is looking forward to. And if you've included all of them and a neat, clean diagram is there, not beautiful, but neat, clean diagram is there, very well labeled with legible writing, that is sufficient to get you the entire complete mark. I, as an examiner, will not cut even 1 mark if all these buzzwords are there and a little bit of explanation is written over there. You don't have to fill 3 pages or 4 pages for a 5 mark answer if you know that this is what has been asked and this is what has to be written. No beating about the bush. Okay. So coming back to it, so I'm trying to tell you right now that we are going forward to getting a meiosis 1 done, right? So meiosis 1 is completed right before ovulation. Polar body is extruded out. What you get over here is a secondary oocyte. And secondary oocyte then undergoes a few changes, okay? So it's got, first of all, multiple layers of granulosa cell, and antrum starts forming. Antrum is anything fluid-filled cavity. Just a fluid-filled area is antrum, okay? And it then finally enlarges in size, forms a mature Craffian follicle. These are haploid in now. This was diploid, 2N. This is haploid, just single N. And it's got a zona pellucida. What is zona pellucida over here? Is it this one, pink boundary that you can see, or is it the small one? It is the small one inside, guys. This outside one is the basal lamina. I'll tell you about it. Okay, and the antrum, secondary antrum is there. Basal lamina is there. Theca interna, theca externa is there. And finally, guys, when the ovulation takes place, this small thing that you can see inside, that gets hatched out. Like, the yolk of the egg. And this is all, the remaining albumin. This thing finally pops out. So when this thing finally pops out, the ovum does not have basal lamina. Okay, so there'll be a place, when we talk about fertilization, when the sperm enters the ovum, and this kind of question, I think in one of the MCQ somewhere I'd seen, probably in your NEET essays or somewhere, the layers which the sperm has to penetrate to get inside the ovum, in which basal lamina is not there. Okay, so let's try to understand it better by the next slide. What finally is the ovum is just this part. See, just zona pellucida and corona radiata. That's what ovum is, right? And now I'll tell you a little more about the Graafian follicle, because we'd already been there. Let's discuss about Graafian follicle. So what you have over here is actually about to ovulate follicle. Okay, the 20 mm follicle. Let's just see here. This one. So these small follicles, as you see, they're ones which are growing for the past 65 days. As you can see, these cycles going on. The resting phase is 0.02 millimeters, and the pre-antral phase is 0.2 millimeters. All with multiples of decimals, multiples of 10. So 0.02, 0.2 pre-antral phase. Antral phase goes till 2 millimeters, and then it grows to reach a ovulatory phase. Even you know that 18 millimeter, 20 millimeter, you give the HCG shot, and finally ovulation does take place. And over here, if you can see, this is the ovum, the Graafian follicle from which the ovum or the oocyte is about to hatch. This is the one which we are going to discuss here. This is zona pellucida outside. Okay. This is the theca externa, the layer outside, then theca interna inside. Then you have this basal lamina. Can you see this blue line? This is the basal lamina coming onto this antrum filled with follicular fluid. So this is a follicular fluid filled cavity antrum. And then see closely, this right around the ovum which is about to get hatched out, there is a corona radiata, which is a couple of, a layer of cells around. And inside that is the zona pellucida. All right. Inside it, we have the zona pellucida, and even further, you have the primary oocyte, the nucleus of which finally combines with the sperm nucleus. And these are all also granulosa cells. And I'll tell you what exactly they are called. So these are, mural granulosa cells over here. The mural granulosa cell. Okay. A cumulus oophorus, somewhere close to the corona radiata, which you call as. Close to that, right? These are all mural granulosa cells. These are basal granulosa cells. And finally, out here you have these cumulus cells actually, which are, arranged in a form of radiating spokes. And that's why they call as corona radiata, right? So I think we have already covered this slide. We'll just try to make it more interesting by making it a little more neat for you. So as you can see over here, there's something called as oocytogenesis and ootidogenesis. This is kind of, I think, NEET essays, this kind of questions they're asked. Even if you do not remember these words, it's no problem. At your level, what's important for you to know and memorize is that primordial germ cells or oogonium to primary oocyte is very incipient, native, early stages, right? They're still in mitosis. They're producing a many number of primary oocytes, which will finally, some of them will get to enter the, ovulation stage. Finally, some of them, they mature. they are arrested in prophase stage of meiosis, and this meiosis is complete right before ovulation, and a secondary oocyte along with the first polar body is extruded, as you can see over here. And finally, an ovum and second polar body is formed. After fertilization, this ovum gets, it meets the sperm and it finally forms a zygote, right? So after your first ovulation, after the ovulation, what you get is the meiosis gets complete. Meiosis 2 is complete at the level of fertilization, right? And the second polar body is extruded out that time. The moment the sperm enters inside the ovum, the second meiosis 2 takes place. Okay, and meiosis 2, remember, does not make it further haploid. It remains the same level. Okay, now those kind of things I hope you do remember, because that was at the level of undergraduate level when all these things were taught to you, that meiosis 1 is actually reduction division, meiosis 2 is not. Meiosis 2 is the same. All right, so meiosis 2, the haploid cells, they remain haploid, no further decreasing of it. Now in case of males, there are 4 spermatids which are formed. In case of females, there are 2 polar bodies which extrude out and only 1 ovum is formed, and then finally that ovum gets to meet the sperm and the 2 nucleus, they join and form a diploid cell, and finally a zygote is formed.